Hey folks, and welcome back, and in today's video we'll be exploring the snap start option available for AWS Lambdas for Java applications. So we'll be creating a Spring Boot application using Spring Cloud Functions, and then we will check its performance with the snap start option enabled. So we will be creating this particular Lambda and an API gateway using Terraform, and then after that we will explore how we can actually dynamically invoke different functions within the same Lambda using Spring Cloud Functions. So with this, let's get started. Let's actually start with the code. So I have this request handler Spring Boot application, and in this we just have a simple bean, which is a function bean. What does this do is this actually takes in a string value, converts it to an uppercase and returns the value. A simple handler for this particular Lambda function that we'll be creating. Now that's all that we need for defining a particular Spring Cloud function which actually handles incoming Lambda requests. But now the tricky part is basically around the configuration. So to build this particular jar, we have to make some custom configuration into the particular pom.xml file. Now if you see here, I have added a Spring Cloud Functions adapter for AWS. So this will provide me the particular adapter for running the AWS Lambda function. And then finally, we have this custom plugin configuration, which will actually create that particular jar that will be deployed onto the Lambda function itself. So I have this particular Maven shade plugin with which actually I'm specifying that the shaded classifier name is going to be AWS. So this will actually create a particular jar with the --AWS, and this is the jar that we will actually upload onto the Lambda function. So when I actually build this particular function here, in the target folder, we will see this particular AWS jar. So this is the jar that we will actually upload onto the Lambda function. So now with this particular jar that we created right now, what does this do? Now when we actually upload this particular jar application, the function that will be invoked will be this one. It will actually give in the input, we will convert it into an uppercase and then return the particular output. Now how does this thing work? Now for this to work, actually what we have to do, we have to specify a particular request handler. So let's go to our Lambda function. Now I created this particular Lambda function on AWS and I have this particular handler here. Now according to the documentation, we need to specify this particular function invoker as a handler, which actually internally will make sure that the incoming request will then be forwarded to a particular function bean. Now you must be wondering what happens if we have multiple function beans, right? So let's consider we have this particular function here, which is also a function bean, and this is allowed to have multiple function bean. So in this case, what we are doing is we are setting that we have this particular bean to lowercase, which will actually convert the input values to lowercase and return the particular value. Now let's actually build this particular jar and let's see how we can actually invoke a particular function based on a particular property. So what we are going to do is we are going to actually upload this particular jar containing both these functions. So let's go here and upload this particular jar. Now this will take a little bit of time. Now since we actually uploaded this particular jar, what we are going to do next is we are going to add this particular environment variable. So we have this environment variable called as a Spring Cloud function definition, and we are going to specify the bean that will be picked up when we run the tests. So we specify this uppercase as this value here, and we are going to save this. Now what we are going to do is we are going to publish this particular function. So when I publish this particular function here, this function will now start getting published, but it will take some time for the snap start option to actually work. So what at this particular stage it is doing, it is actually starting that particular application, recording the initialization's memory snapshot, and it's going to store this particular snapshot in the cache, such that the snapshot of the memory is going to be directly loaded and the application can start serving requests directly. So in this way, it actually reduces the initialization time by taking the snapshot of the memory and loading it for every cold start. So right now it is actually capturing that particular snapshot of the memory and it will now store it into its cache. So let's wait for this particular process to complete. So now the process is completed. Now if you actually want to see what this particular configuration was, you can always check it over here. So you can see that the snapshot optimization status is on, and this is on for this particular version 4. Now at the function level, you will see that the configuration here will be shown for published version, because the snapshot works only for published versions. You can always edit this from here, and you can always specify whether none, so that means no optimization will happen, and then here as published versions. Okay. With this, we have this version 4 that we just deployed right now. Now let's actually test this particular thing. So I'm going to go to the test section here, and I'm going to call the default event that we have here. So this one executed successfully, and as you can see, for the input which was in smaller case, it is now in capital cases. Okay, so this now took a restoration time of 400 milliseconds around, and the duration was pretty much 1 second. So this can vary, but as you can see, this time is very much less than compared to the time that a Spring Boot application takes to start up. A Spring Boot application normally takes around 6 seconds to 7 seconds. This is literally 1/10 of the 6 or 7 seconds that we usually take to start the Spring Boot application. So now with this, we were actually able to see how snapstart actually reduces the initialization time. We also saw how we can invoke a particular function by specifying this particular environment variable here. So we had specified to uppercase. Now what we are going to do is, if we wanted to change this particular function, and we want to this time maybe call, say, the lowercase function, I'm going to copy this and I'm going to change this particular configuration. So let's go back here in the configuration section and edit this to specify lowercase. So now let's actually publish this particular function. So I'm going to publish this, and this is going to take some time here. So the function is now published. Let's go and test this thing. So now in the test event, what I'm going to do, I'm going to specify a capital value here, and let's actually test this thing. So if you see here, the capital value is now converted into a small value. Why? Because we specified in the environment properties that we want to use the toLower function. So in this way, we can actually customize which particular function will be called during a Lambda invocation. Now there is yet another thing that you can do is dynamic invocation at runtime completely. So for this, what we are going to do is we need a particular API gateway for this. So before this, let's look at how I created this particular Lambda function using Terraform. So let's go back to our code here. So I have this particular Terraform module section here, and in this I have this particular Lambda module. Now in this Lambda module, what I have specified here is I've created a particular role here. So this is the Lambda role to execute the particular Lambda, and then finally we have the Lambda function itself. That's it. These are the only two configurations that I created here. I specified this particular handler. So this is the invocation handler. So this actually handles the incoming request by Spring. And then after that, I'm specifying here an S3 bucket. So in order to create the Lambda function, I need to specify some mechanism through which I can provide it particular code. So what I have done here, I've specified a dummy S3 bucket. This is actually an existing S3 bucket with a particular empty zip. So I have this particular S3 bucket containing a zip file, and I'm specifying the runtime as Java 11 because that's the only version right now that is available. And then I'm specifying the package type as zip and the timeout as 15 seconds. This is the configuration which actually enables the snapstart option. So here I've specified to apply this on published versions. So with this, I was able to create the Lambda from scratch using Terraform. Next, what we are going to do is we are going to create an API gateway. Now, to understand how to create this particular API gateway, what I'm going to do is I will be creating this using Terraform as well as from the UI. So let's go to API gateway. Now here I'm going to show step by step what things are happening. So first of all, I'm going to create an HTTP API. So I'm going to say build here. So this is the first section that we specified here. I'm specifying Spring API Gateway as the name, and I'm specifying the protocol as HTTP. Now here it is saying we need to add an integration. So I'm going to say add integration, and I'm going to select from the drop down Lambda. And here I'm going to specify the Lambda function that we have. That is a Spring Boot function. Okay. This is the same thing that you can see in this particular code here. I've specified the Lambda integration here. Then I'm specifying a particular post method, and I'm specifying that the integration URI is going to be this particular Lambda ARN, which is passed as a part of the previous module that we created. Okay, so this is the same part that is being done in this particular code section, and the reference to the particular API gateway here. Now here I'm going to give it a particular name called as Spring. Next, so here I'm going to specify a post route with only slash being the endpoint, and here the target integration is going to be the Spring function that we just created previously. So if you see in the code here, I've specified the route key, that is post slash, which is the same as the UI here, and the integration that we created previously, that is a reference to this particular Lambda integration, has been provided as a target here. Now I'm going to say next here, and then I'm going to specify a default stage here. So I'm not going to change anything here. I'm going to specify that this particular API gateway will be deployed onto the default stage, and I'm going to enable auto deploys. So now in the code here, I have specified here the stage with the name as default and auto deploy as true, and then specifying the reference to the API gateway from the code here. Finally, I say next and I say create. Now along with this, you need to specify some permissions to the Lambda so that the API gateway can invoke that particular Lambda. So in Terraform here, I've specified this particular permission here, which actually takes the Lambda execution ARN and then allows the Lambda function, that is a Spring Boot function, and allows an invoke permission access to this particular API gateway. So now this can be also created using Terraform, like the way I have explained it here. And all of this entire code is checked into GitHub. Now the GitHub link is present in my blog, which I'll be linking into the description below. So you can refer to the refactorfirst.com to refer to this blog, which contains the GitHub link itself. So now what we are going to do is we are going to actually copy this URL and we are going to make a post request. So I'm going to call a post request here, and I'm going to specify my name Amrut here in the JSON, and I'm going to send this. So it returned me the lowercase of this particular name, right? Let's try with the uppercase Amrut here and make sure that it returns us the lowercase. So it has returned me the lowercase value here. Let's see how we can actually dynamically invoke the various functions, right? So first of all, what I have to do is, let me go back to my Lambda. See, in my Lambda function, remember I had put this environment variable configuration. I'm now going to remove this particular variable, and I'm going to provide this particular variable at runtime. So let's see how I can do that. So first of all, I'm going to publish this particular version of the Lambda without the environment variable. Since we are using snapstart, this will actually take a little bit of time. So now the function is all deployed. Now let's actually test this particular thing. Now remember, we have two functions and we have not specified any configuration in the environment properties, right? Now when I actually call this particular event, what happens here is it fails. Why? Because now that particular handler doesn't know which particular function to be called, right? That's the reason it's actually failing here right now. So now what we are going to do, we have this deployed and we have the API gateway, right? Now in the header section, I'm going to specify this particular property. I'm going to specify Spring Cloud function.definition as a property with the value of the bean that I want to invoke. So I'm specifying here two uppercase. So in my body here, I have the name as small case and Amrut in the uppercase. Now let's make a post call to this. And if you see, this will actually now convert it into an uppercase here. So the output here in the uppercase. Now if I specify the other bean name, so the other bean name which was actually two lowercase, I'm going to copy this from here and paste it here and send the request. This actually called the lowercase. Let's actually make another call again to uppercase and make the call. And in this way, we can actually dynamically switch between what function definition we want to call and then invoke that particular functionality. Now, this is the way you can dynamically invoke a particular function, right? Now, in case you want to specify this into the properties file, you can use the same property and specify in the application.properties file, and this will work in the same manner. But it's just that you will not be dynamically be able to call different function. So today we saw how we can actually dynamically invoke different functions within the same Lambda function using Spring Cloud functions. We also saw the performance of snapshot, that it reduces the initialization time by taking a snapshot of the memory and loading this particular snapshot for cold start invocations. I keep on exploring such kind of things, so make sure you subscribe to this particular channel and give it a thumbs up for more such videos to come. Till then, take care and see you in my next one.